All right, guys, it is the last video for pre-calc for the whole year. Uh, I was going to do this lesson. Technically, it's not in this chapter. It's in a chapter down the line, but I always teach it at the end because it's a nice way of kind of wrapping up limits and derivatives since what you've learned so far. And I was going to have it after the test, but you're going to be checked out at that point. So I put it before the test. I'll put it on this test as well. It's not that bad. So this is a really important lesson as I'm studying for the AP exam. It's on every year since it's been added in 2016. It's been on the test every year since then. And the rule is easy. The kids struggle to make sure they have all of the right things. So when I get to the back side of this paper, make sure you're with it because it is definitely the place where students struggle. But this is called L'Hopitals Rule. It helps us to find limits, but it also connects the idea of limits and derivatives together. Let's get it. All right, so here we go. L'Hopitals Rule is a valuable tool for computing certain limits that would otherwise be difficult to evaluate. So if you are going to find a limit and you get 0 over 0 or infinity over infinity, so far our rule is simplify, cancel, and plug back in, or factor, cancel, plug back in. But sometimes it's not that easy. And so if you can't do it that way, we can use L'Hopitals Rule. Okay, L'Hopital is a mathematician. He has a very interesting life. In fact, he has this rule named after him. He really just bought the math from a farmer. It's an interesting story. Check out his Wikipedia page. It's pretty interesting about it. All right, but here's what L'Hopitals Rule says. It states that if the value and the limit, or I'm sorry, the numerator and the denominator of something is 0, okay, and f and g are differentiable, then the limit of a function, okay, so for example, we took the limit of this function and we got 0 over 0. If we could get 0 over 0, then it's also going to be equal to the same limit if you took the derivative of the top over the derivative of the bottom. All right, so if we got into indeterminate form where we're going to get 0 over 0, if we take the derivative of the top and bottom, it will tell me what the actual answer is. All right, so it's a little bit funky. It's just a matter of understanding what's going on. All right, so let's look at letter A, and it'll do a better job of explaining than I just did. The limit as x approaches 2. All right, so if I'm finding a limit, I plug in 2, I do direct substitution. So 2 squared minus 4 over 2 minus 2. I get 4 minus 4, which is 0, 2 minus 2, which is 0. Cool, I got 0 over 0. Okay, sad face because we're not done. It's indeterminate form. And so what we learned so far is if that happens, then we need to simplify, cancel, and plug back in. So for us, that means we're going to find the limit as x approaches 2. We're going to factor that top into x plus 2 and x minus 2. We're going to factor the bottom into x minus 2. We're going to cancel the x minus 2's. We're going to take 2. We're going to plug it back in. 2 plus 2. My answer is 4. That is the limit. Okay, that's the old way of working, and it still works great. There's nothing wrong with it. The reason we didn't teach it the other way is because it involves derivatives. And so if we're doing the same problem, the limit as x approaches 2, and I wanted to find the limit. Well, again, if I plug in 2, I'm going to get 0 over 0. So when I get 0 over 0, we can factor, cancel, plug back in, or we can take the derivative of the top and take the derivative of the bottom. This is not quotient rule. We're going to take the derivative of this and then the derivative of this. So, for example, limit as x approaches 2. What's the derivative of the top? Well, it's 2x. What's the derivative of the bottom? It's 1. I take this 2. I plug it in. My answer is 4. Same answer, different approach. Okay, that is L'Hopitals Rule. So let's look at it again, looking at example 2. This one's a little bit tougher. We could talk about this one. We don't even do it at the time because it's easier with L'Hopitals Rule. If I plug in 0 on top, I'd get 0. If I plug in 0 on bottom, I get 0. Darn, I got 0 over 0. And right, I would say if you are taking the AP exam and they are asking you to find the limit of a fraction, there's like an 80% chance that you're going to get 0 over 0 and you're going to need L'Hopitals Rule. They really like these questions, so be ready for them. So since I got 0 over 0, what I'm going to do next, we did this one before where you can multiply by conjugates, but we don't want to do that. So instead, we're going to take the derivative of the top. All right, so remember what that is, 1 plus x to the 1/2 power. I'm going to multiply by half, rewrite the baby. Subtract 1 from my exponent. On bottom, my derivative is just 1. Now that I've done that, I'm going to plug in my limit and see what I get. So I'm going to take 0, plug it in. I get 1. 1 to the negative 1/2 power is still 1. 1 times 1/2. My answer is 1/2 done. Easy. Just take the derivative of the top and the bottom. Notice that we are not using quotient rule when we take the derivative of this thing. Okay, you're taking the derivative of the top, you take the derivative of the bottom, you plug in. Great, that's 2. Let's look at 3. Now I'm finding the limit as x approaches infinity. This one's a little less common, but not only is it indeterminate form if we get 0 over 0, but also if we get infinity over infinity. So if I plug in infinity on top, e to the infinity power, that's a giant number minus 1. Oh, that's infinity. If I plug infinity on bottom, infinity, oh, that's infinity. And we could look at that. We could look at that and think about it in a different context. Which number is going to be bigger? The top is going to be bigger because e to a power is way bigger than just that power. All right. So we know that this answer is going to be D and E, but we could apply L'Hopital rule. Okay. L'Hopital's rule says, let's take the derivative of the top. The derivative of E is what you see times the derivative of the exponent. What's the derivative of the bottom? 1. I'm going to find the limit as x approaches infinity. So I'm going to plug infinity in. Hey, guess what? I get infinity over 1, otherwise known as D and E. So L'Hopital's rule helps us with that as well. We're finding horizontal asymptotes there. It makes does kind of the same thing that we would have done before. Good. Let's try another one. Number 4. Limit as x approaches 0. If I plug 0 on top, I get 1 minus 1. If I plug in 0 on bottom, I get 0 plus 0. I get 0 over 0. Cool. I need L'Hopital's rule. So L'Hopital's rule says take the derivative of the top. The derivative of 1 is nothing. The derivative of negative cosine is sine. On bottom, I get 1 plus 2x. I'm going to plug in 0 on top and 0 on bottom. When I do sine of 0, that is 0. On bottom, I get 1. 0 over 1 gets me 0. That is my limit on 4. Let's try it on 5. Again, if I plug 0 in on top, I get 1 minus 1. On bottom, I get 0 squared. I get 0 over 0. Cool. Since make sure you're getting 0 over 0. Okay, if you're not getting 0 over 0 or infinity over infinity, then you don't need L'Hopital's rule. Here, I continue to get that, and so I'm going to keep doing what I've been doing. So I'm going to find the limit as x approaches 0. The derivative of 1 is nothing. The derivative of negative cosine is sine. The derivative on bottom is 2x. I'm going to plug in 0. I'm going to plug in, I get 0 over 0. I tried L'Hopital's rule. It didn't work, okay? And in fact, it's still 0 over 0. So one thing we can learn about L'Hopital's rule is sometimes you can apply it more than once. So I did L'Hopital's rule. I got 0 over 0. If I get 0 over 0 again, I just apply L'Hopital's rule again. And so I'm going to take the derivative of sine. Well, what the derivative of sine? That's cosine. The derivative of 2x is 2. So I just found basically the second derivative. I'm going to plug in 0. So cosine of 0 is 1/2. A little bit different, but that is my answer here. Okay, my answer is 1/2. And if you need some idea of what that is, here's that graph that we just did. 1 minus cosine x all over x squared. And we said the limit as x approaches 0. So if you notice there's a hole on my graph, it's hard for me to zoom in here. But if I get real close there, I do get undefined for a split second. Here, I will cheat here. F of x equals that. Tell me what f of 0 is. Okay, cool. It's undefined. Okay, that's what we're trying to do there. F of 0, it's undefined. We can't find it. But you can obviously see as I approach it from the left and the right, I'm getting closer and closer to 1/2. That is what we're trying to do. That is what L'Hopital's rule is telling us. All right, so that way you actually see it. So the idea of L'Hopital's rule is super easy. You take the derivative, you plug in, you go. The problem is on free response, they're super particular as to how you state this. And so I want to be very clear on this. If you are using L'Hopital's rule on a free response question, okay, it's a little rough. There are things that they are looking for that you have to put in order to get the answer. Okay. Technically, you need to state any function is continuous if it doesn't say it is. Okay. So you have to say that a function is continuous. Okay. A few years ago, I had a teacher that graded 10,000 of these tests at the grading in June over the AP exam. And out of those 10,000, only one student got all of the points because they wrote continuous. Otherwise, you don't get it. Okay. You must show the limit of the top and the bottom is equal to 0 separately with limit notation. That is the number one thing that my students forget. And I'm going to hammer it home right now to make sure we got it. And then we're going to state that we use L'Hopital's rule as we go. All right. So for example, the function f satisfies f of 0 is 20. Selected values of f prime are shown in this table. The function has a continuous second derivative for all real numbers. We are finding the limit as x approaches 0 of this guy right here. All right, so as I look at this problem, I see the limit of a function. Some different things are going on. So here's what I'm going to do. I'm going to find the limit as x approaches 0. You need to write it out of f of x minus 20 of e to the x power. I am also going to find the limit as x approaches 0 of the bottom. So on bottom, I get this 0.5 f of x minus 10. If you don't show it separately, then you can't do L'Hopital's rule, and you're not going to get full credit. Okay, if you don't do this, this is a 3-point question. Even if you get the complete right answer, if you don't do this, you're only going to get 1 out of 3. So don't screw this up. All right, so f of x, so f of 0, oh, that's 20, minus e to the 0, I'm sorry, minus 20 e to the 0. Oh, guess what? That gets me 0. I'm going to do this. Now I'm plugging in 0 here. So this is 0.5 times 20, because that's what f of 0 is, minus 10. Oh, guess what? That also gets me 0. So I got 0 over 0. So I'm going to say this. Since f is continuous, and how do I know it's continuous? Because the function has a continuous second derivative, it's differentiable. Since f is continuous, by L'Hopital's rule, and then I'm going to go ahead and write it out. So the limit, make sure you're writing limit notation. Okay, is that a little bit annoying here? Absolutely it is, but we're going to do it anyways. Now we can find the derivative of the top and the bottom. The derivative of the top, that's f prime. The derivative of e is what you see. All over on bottom, I'm going to get 0.5 f prime. And then the minus 10 is going to go away. So I'm going to draw an arrow here instead of an equal sign. When in doubt, put an arrow, because sometimes you write an equal sign when things aren't actually equal. These are, but an arrow sign is just a better thing to get used to. So f prime at 0 is 4 minus 20 e to the 0 all over 0.5 f prime at 0 is 4. So on bottom, I got 2. On top, I got 4 minus 20, so that is negative 16. Negative 16 divided by 2 is negative 8. So again, what things did you have to show? The limit of the top is 0. The limit of the bottom is 0. You have to write limit notation. And then we've got to say, since f is continuous, by L'Hopital's rule, and then do L'Hopital's rule. I didn't do that on the front because they weren't free response questions. Okay, if it's just multiple choice, I don't have to get that creative. But on the back, since I'm telling you these are free response, make sure you're doing that. Okay, very important concept. Let's do the next one. Two graphs are given on the right. They are differentiable at x equals 3. Find the limit as x approaches 3 and x approaches 3 of f over g. So I see a fraction. The first thing I'm going to do is I'm going to find the limit as x approaches 3 of f of x and say what that is. And then I'm going to find the limit as, I'm going to do it in purple so you can see x approaches 3 of g of x, since the line is purple. So let's do f first. F at 3, oh, that is 0. G at 3, oh, that is 0. So I get 0 over 0. All right. Because this is true, I'm going to say since f and g are continuous. How do I know that? Because the graphs are continuous. I don't need to state why, but they are continuous by L'Hopital's rule. by L'Hopital. Now we're going to take the derivative. So I'm going to find the limit as x approaches 3 of f prime of x divided by g prime of x. All right, so f, what am I looking for in this graph if I want f prime? I'm looking at the slope. Let's look. I'm going down 3 over 2, so that's negative 3 halves. Down 3 over 2, down 3 over 2. And then g prime, looks like I'm going up, going from this dot to that dot. I'm going up 1 over 2, up 1 over 2. So that is a positive 1/2. I'm dividing a fraction by a fraction, so I'm going to multiply by the reciprocal. My answer is negative 3. Had to use limit notation. I had to show the top was 0. I had to show the bottom was 0. I had to say continuous. I had to say by L'Hopital. And then I actually got my answer. Last one. We're doing good. Again, the concept, simple. The annoying part is separating it out. But other than that, it's easy. Consider the differential equation. So dy over dx is that. That's my differential equation. Particular solution with f of 1 is equal to 0. Excuse me. Find the limit as x approaches 1. Cool. I see a fraction. I'm thinking, hey, there's a good chance I'm going to need L'Hopital's rule, so I'm going to write it out. Limit as x approaches 1 of f of x. And I'm going to find the limit as x approaches 1 of x cubed minus 1. Let's do it. So on top, if I plug in 1, I get 0 because of this right here. F of 1 is 0. If I plug in 1 here, I get 1 cubed minus 1. Oh, that is 0. The limit of the top is 0. The limit of the bottom is 0. So since f is continuous, they gave me the derivative. So if they gave me the derivative, I know f is continuous. I'm just going to write it out. You don't have to get too fancy here, but since f is continuous by L'Hopital, now we're going to take the limit as x approaches 1. I'm going to take the derivative of the top, so the derivative of f is f prime. I'm going to take the derivative of the bottom, so that would be 3x squared. I'm going to plug in 1, so f prime at 1. If I want to find f prime at 1, I'm going to use this, because that is the derivative. All right, so think about that. F prime is going to be equal to 1 minus my y value. What am I going to plug in for my y value if I want to find the limit when x is 1? 0. That's my y value. When my x is 1, my y value is 0. So it's going to be 1 minus 0. So on top, it is just 1. On bottom, I'm going to plug in 1. 1 squared is 1 times 3 is 3. My answer is 1/3. L'Hopital's rule. Okay, just some quick reminders. You use L'Hopital's rule when your derivative is 0 over, or I'm sorry, when your limit is 0 over 0 or infinity over infinity. You take the derivative of the top, the derivative of the bottom, and then you plug in. Again, if it is infinity over infinity, you could think your way through it, or you could actually use L'Hopital's rule. It's not too bad. If for some reason, after the first time you apply L'Hopital's rule, you get 0 over 0, plug it in again. Just take the derivative again. And then remember, you got to show these 3 things when you see L'Hopital. Again, if it's a free response question and it's a limit of a fraction, there's a real good chance it's L'Hopital rule. Okay, so what you're going to do is take the limit of the top with notation, make it and show that it's 0. Take the limit of the bottom and show that it's 0. And then say whatever your functions are continuous, and then by L'Hopital's rule, and then do it. Okay, just be careful with it. It's a place where you can easily get full credit or you can easily get no credit just by not putting what you need. Okay, last video of the year. Hope it helps. Let me know if you need more work.